Alright folks, I got tripped up by the bell today in class, so this is the rest of the lecture you were supposed to get today in class. I had given you guys what bond enthalpy were and how we can use them to calculate delta H for a reaction using a formula. So this is the example we were going to go through. So we've got a problem. We want to find the delta H of a reaction for this reaction right here. The first step you want to do is write out what the Lewis structures look like for all of the compounds in that reaction. So that's what I've done here. Oh, these were given to you. We had written this down right before you guys left. So these are the bond enthalpies that we're going to use to calculate. So Lewis structures look like this, okay? So there are 2 of these molecules, 7 of those molecules, 4 of these, and 6 of those, okay? So I'm just keeping the mole ratios here accurate. And then from there, we want to evaluate each structure for how many of each kind of bond there are. So like in this structure right here, there are 2, well, there's technically 1 carbon-to-carbon bond, but there's 2 of these molecules. So we have a total of 2 carbon-to-carbon bonds present in the way that this formula is written. So that's 2 carbon-to-carbon bonds. We look at our table. Carbon-to-carbon bond is 348 kilojoules of energy, so 2 times that value gets us this energy, and so on and so forth for the entire problem. Okay? Pay attention that I'm being really careful with how many of each kind of bond I have. So like here, the C to H bonds, I've got 1, 2, 3, 4, 5, 6 C to H bonds for every molecule, but I have 2 molecules, so that I have 12 C to H bonds, so that's why I've got 12 down here. Okay, so if you're going to make a mistake doing these kind of problems, it's that you'll forget to multiply by the coefficient. So make sure you're paying attention to that. So we've got 7 O double bonds. Okay, so we've got that value there. On the product side, we have 8 C double bonded O's. Okay, because 4 times 2 is 8. And then 12 OH bonds. Okay, so essentially all we're doing is just getting the energy values associated with all these bonds on the reactants and product side. And then after that, we add them together. So this plus this plus this is going to equal our total bond energy on the reactant side. And then this plus this gets us the bond energy on the product side. And then we plug these 2 values into the formula. Okay, so the delta H of the reaction was the bond energies of the reactants minus the bond energies of the products. And we get this value as the result. This tells us that this reaction is exothermic, which would make sense because it's a combustion reaction, which is definitely going to be exothermic. Okay? So pretty straightforward stuff. I hope this helps you with your homework. I'll see you guys tomorrow.